Good morning. Well, good morning from me. Howdy, geometry. We're looking at lesson 4.2. I'm pre-recording this because my afternoon has some activities going on, so I can't go live today. So it's the morning for me. We're looking at 4.2, like I just said. We're proving triangles congruent. Okay? We are using those four big things that we looked at the end of the last notes and during our classwork. Those four big things are SAS, SSS, ASA, and AAS. The S stands for side, the A stands for angle. So, what is a proof? A proof is a list of steps that provides enough evidence to the reader that what you're saying is true, right? Um, have you ever had to convince your parents of something, right? They want you to justify why it is that you should be able to do this. They want you to justify why they should buy you this thing. What's in it for me, right? That sort of thing. You have to provide some sort of evidence. You have to convince your parents of something, right? Well, you as a student in my math class need to be able to convince me that any of these triangles are congruent. And it isn't, and I'm the teacher, right? And in this world, right, you can't just tell me, well, they look the same, don't they, Mr. Skis? No, that's not good enough. These four methods are how we prove triangles congruent. If you can show me SAS, then I'll believe you. If you can show me side, 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 then I'll believe you. If you can show me angle, side, angle, then I'll believe you. If you can show me angle, angle, side, then I'll believe you. All right? We're going to start out really easy. There's a bunch of given statements. All right? What does given mean? That means they've been handed to you, right? It's just something that it's true, right? So you got to start from somewhere, right? You got to start from somewhere, right? We're not completing from complete scratch, right? There's always some type of initial information, and that's what the given is. So let's fill in this given information. AB is congruent to DE, so we'll do a little tick mark. AC is congruent to DF, so we'll do 2 tick marks for those guys. And angle A is congruent to angle D. We'll do an arc for those guys. So this is our proof. And how is this broken up here? We have statements. So these are the things that we're trying to say, and this is the reason why. This is true because of this. This is true because of this. This is true because of this. Well, these 3 things were given to us, and that was already filled in. But now, you as a student, us together, are trying to say why these 2 triangles are congruent. Well, BCA is congruent to, how do I write this? Is it DEF? Is it FDE? Is it, right? What order is it? Remember, the letters have to match up. So what corresponds with B? Take a look here. A is corresponding with D, right? And AC is corresponding with DF. So B goes with E. So this is B, F, sorry, not B, I'm sorry, E. B goes with E, C goes with F, A goes with D. And why are these 2 triangles congruent? Well, what do we have marked on the page here? These 3 statements are enough information for me, right? Because you're trying to prove to me, the teacher, why these triangles are congruent. This right here is side, angle, side. So you've just shown me side, angle, side. And that is the reason why these triangles are congruent. Not because they look the same or because, well, obviously they're the same. It's, oh, well, I know that this side and this angle and this side are congruent. Oh, you do? Well, use side, angle, side to prove them congruent. So some of these start out super easy, okay? Where, oh, it's all given to us. They're not always going to be this easy. So here's SR and XZ. Here's ST and XY. And here's RT and ZY. Why are these triangles congruent? And what's the correct way to write that statement? R goes with Z, S goes with X, and T goes with Y. Those two triangles are congruent. Why? Well, they're congruent because all three sides are the same. Side, side, side. Let's answer these two questions off to the side before I get too far. What transformation shows that these two guys match up? This is simply a translation. And this is a reflection. All right, we have a couple of blank spaces on this one, okay? Always fill in the givens first. But now, why are BCA and, let me use a different color. Why are BCA and ECD congruent? That's what we're filling in here. Why are those two things congruent? Think back to our second unit when we were dealing with lots of angles. I hope you haven't just completely forgotten that, out of sight, out of mind. We've had linear pairs. We've had perpendiculars. We've had vertical angles. We've had corresponding and alternate interior and all these different types of angle relationships, right? What are those two? They are vertical angles. And what do we know about vertical angles? They're equal, right? They're congruent. So why can't we just look at this picture and casually say that they're congruent? Because they're vertical angles. All right? They're vertical angles. We can say they're congruent because they're vertical angles. We know that vertical angles are congruent. So now, all of a sudden, you've proven a third thing, right? We were given these two things, and we needed to know why was that true. It's like we look at the picture and we're like, well, yeah, those two angles are the same, but like, how do you know for a fact they're the same? Not just because they look the same. You go, well, I know they're vertical angles, and vertical angles are always the same. Exactly. So now our statement here, A, be careful here. What is A congruent with? Is it E or D? It's D, right? This segment right here is the one that matches up with this one. So C to A is the same thing as C to D. So D and A match up. And then C matches up with itself. All right, so we have D, E, C. And why are they congruent? Side, angle, side. Side, angle, side. So what would this transformation be, by the way? It's sort of wrapping around, right? It's not flipping across. It's going to kind of swivel on point C. It's a rotation. All right, more blanks. Take a step back, and again, why are we doing this? The goal is to tell me that the triangles are congruent. And you can't just go, well, they look like it, right? You need to provide me with sufficient evidence. That evidence will end with SAS, SSS, ASA, or AAS. You will have given me enough for one of those four, right? I don't need all of them. I just need one of them. So we are given that R is congruent to O. And we are given, I'm going to do them both in blue since they're both given. And we are given RTS is congruent to OST. So we got a couple of angles. I'm going to do two arcs, right? Because it's a different angle, right? So you betcha we're going to do angle, or angle side angle, one of those two things. So why are these congruent to each other? Well, isn't that the same thing? Wait, isn't the same thing, TS and ST? You're right. They are the same thing. They share a side. You see that? Imagine if I took these two triangles and like ripped them apart, right? This side is TS and this side is also TS, right? They are sharing a side. So we know that this angle and this angle are the same, and this angle and this angle are the same. They were literally sharing a side, so of course that side is the same. Well, there's a name for that, and I don't expect you to know that off the top of your head right now. The fact that they're sharing that side, the fact that it's the same side twice, is called the reflexive property. All right? And why is it called the reflexive property? Because you're saying something is congruent to itself, right? Of course 2 is equal to 2. Of course 5 is equal to 5. Of course my hand is the same as my hand, right? Well, of course TS is congruent to TS because they're the same thing. That's the reflexive property. And now what do we have here? Angle, angle, side. Angle, angle, side. But I guess I forgot to fill in this blank right here. So T is congruent to S. And R is congruent to O. And S is congruent to T. So SOT. Angle, angle, side. Now, whoa, we got a fifth statement at the end. RS is congruent to OT. Is that true? Is that true? Well, if you had tried to tell me this at the very beginning, why would that be true, right? Erase some of my markings here, right? Why would that be true? Why would RS be congruent to OT? I mean, besides the fact, well, it just looks like it, I'm not sure you would have a reason for that. You wouldn't have a reason for that. But look at what we did first now. We just proved the triangle's congruent, right? Well, if the triangles are congruent, right? We just found enough information. We just had enough information to say that the triangles are congruent. Well, if they're congruent, then that means everything about them is the same, right? Now that we've shown the triangle's congruent, we can safely assume, well, of course those are the same, right? Because if the two triangles are identical, well, then of course those two pieces are identical. What's that called? We used that last class, Cpctc. Corresponding parts of congruent triangles are congruent. Now that we've proven the triangle's congruent, we can say that the corresponding pieces, RS, corresponds with OT. You can see how the letters match up. It corresponds. Since they correspond, well then, they're congruent. All right. We're given this information. This side's completely blank. We're given that KA is congruent to BC, and we're given that KC is congruent to BA. Well, do you already know what the answer to this one is? That's just the same side, isn't it? What is it? What did we just say a few moments ago? It is reflexive. To say something is congruent to itself is the reflexive property. And, well, what have we just shown? We've just displayed that, oh, all three sides are congruent. So, side, side, side. Easy. Once you've somehow, whether it's been given or whether you've had to piece it together using the reflexive property, once you have those three important ingredients, SSS, SAS, whatever it might be, you've ended it. You're like, you don't need to prove anything else. You don't need to show me anything else. Once you've got three, you're good. All right, so once again, we have some given information. We've got some given information. Always fill in your givens first. Now, this might look a little different. Like, well, that's interesting. You got a statement here. It's not even an equation. We have a statement. So C is the midpoint of BP. So how did we get from this to this? It's saying, so they told us C is the midpoint of BP. All right, here's BP, and C is the midpoint. Well, what does that mean? It means that it's congruent on either side, right? And that's what this statement is saying. If C's in the middle, that means that the left side and the right side must be the same, right? Because C's right smack dab in the middle. So how did we know that? Well, because that's what midpoint means, right? So what do you think I should write here? That's what the word midpoint means. I just know what the word means, right? And so do you. You're just using that word. Well, you're using that word's definition, right? That's the definition of a midpoint. We're not trying to overcomplicate things here. We are smart people. You are a smart person, and we know what the word midpoint means. We used the definition of midpoint. We were like, well, midpoint means it's in the center. If it's in the center, then it's got to be equal on either side. You're right. Don't underestimate yourself. You're right. You're exactly right. What did you just use? What was your reasoning? The definition of the midpoint was your reasoning. Exactly. And they told us that C is the midpoint of AQ, which means, well, those two are congruent. We're using the same definition. We once again know what midpoint means, and we're going to use it to our advantage. So we've shown two sides congruent. Can we show a third one? Or is there an angle out there maybe? Side angle side? Why are 1 and 2 congruent? Once again, we have intersecting lines, and these angles are on opposite sides. What are they? Vertical angles. Vertical angles. And now we have side, angle, side. Side, angle, side. And now let's very carefully write the statement. Doesn't matter how you start, so I'm just going to write ABC. It matters how you end. A corresponds with Q, B corresponds with P, and C corresponds with itself. Last one, people. We're going to do this in under 20 minutes, hopefully. Last one. We are given this information. And we are given the fact that GH is congruent to JK. I'm just looking over here, right? So GH is congruent to JK. Why? Because we need a reason here. Why are 1 and 2 the same? Well, what were we told? We were told that GH and JK are parallel. This looks like a transversal to me. What are 1 and 2? They are on opposite sides of the transversal. They are in between the parallel lines. They are alternate interior angles. That, in case you've been wondering, like, what is he writing there? That's an angle symbol, and I'm doing an apostrophe S to write angles, right? It's just something I do. So they're alternate interior angles. That is enough info, right? You know that alternate interior angles are congruent. So tell me that, right? Like, we've seen that before. Use that to your advantage. Okay, so we've got that angle and we've got that side. Ooh, we're making this last one tough, right? It's completely blank. We got to come up with it entirely on our own. All right, think of it this way. Think of it this way, people. You have a side and an angle. You can do two things. You could find another angle and do angle, angle, side. Or you could find another side and do side, angle, side. Which do we know, though? Which do we see on the page? Which do we know to be true? It's something that we've already done twice. Look at these two triangles. Look at these two triangles. Let me make them blue. Here's this triangle. And here's this triangle, right? What do they share? What do we know that's exactly the same based on the way they're drawn? They literally share this middle side. Rip them apart, right? We know that that side and that side are the same due to the fact that it's literally the same side. So, reflexive again, right? Reflexive. Let me erase all my gibberish so I can see the letters. So we know that GJ is congruent to JG. We know it's congruent to itself. And now that we've shown that second side to be congruent, we have a side, an angle, and a side, SAS. So, what additional congruent statements can you write for the triangles above using Cpctc? The last question here. What additional? So basically it's saying, you remember how this proof right here ended with Cpctc? Essentially this question is asking us, well, now that you've shown the triangles to be congruent, is there anything else you could say? Yeah, we could say a lot of things. We could say, we already know that this side and this side are the same. Well, we now know that those two sides are the same. GK and JH. Making sure to keep up the corresponding parts, right? G corresponds with J. What other angles could we say? We could say angle K is the same as angle H, right? You know these are the same now. We didn't know that at the start. I know you might be like, yeah, but the thing is what would you have said? What would be your reasoning for that? Like, they look the same. You know they're the same. You're like, yeah, I feel it, but why, right? There is no real reason why until you've proven the triangle is congruent. Once you've proven the triangle is congruent, the reason why you know that to be true is because you're like, they match up. They're clearly the same. Yeah, they're corresponding. You are smarter than you realize, right? You're like, yeah, I know they're the same, but I just can't express why. What you're feeling is the fact that they match up. They're corresponding. But you can only say that once you've proven the triangle is congruent. All right. We kept it short. We kept it quick. Awesome. Good work. Thank you for watching. I'll see you in class. Have a great day. Bye-bye.